right, guys, we're into chapter 8, lesson 1. We're going to be talking about function tables. We're going to be a little bit all over the place. I'm going to talk to you a little bit about some vocabulary because we've got some important reading to do here. I want to start on this page, which is page 580, as you can see. We're going to go ahead and chat about this a little bit because it's important that you understand this. Let me go ahead and turn the light on here. Maybe that'll help you a little bit. Okay. So I hope you did well in Chapter 7 test. If you didn't get it back yet, you will. Let's go. So today we're going to be talking about function tables. And in a function table, we have some important information. Okay. So we have the input and the output. This is considered X and this is considered Y. We're going to be doing some graphing. And we have a thing called a function rule. How do we get from X to Y? Okay. And you're going to notice that it's input and output, X or Y. Look at the function rules. And they're telling you what the rule is. And what you're going to do is you're going to plug in the number that they give you for X to get Y. Now, sometimes we're going to be given Y and have to work backwards. So we will be challenged there a little bit with some things that we're going to have to look at. And we just have to kind of stay the course here. And we should be in pretty good shape here, okay? All right, so let's go ahead and get started. A function is a relation that assigns exactly one output value to one input. All right, here's your output, here's your input. The number of wings output depends on the number of seconds input. Okay, so the more seconds you have, the more wing beats you'll get. Think about it that way. The function rule, which is in the middle, describes the relationship between each input and output. So how are you getting from X to Y or working backwards, right? And we may have to do some inverse operation. You can organize the input and output values in the function rule in a function table. So the whole thing's called a function table. Now, another name for the input and the output is called independent variable and dependent, okay? All right, so the input, another name is called independent. It stands alone, okay? We can't have the dependent variable without the independent, all right? So this will not exist without this. If we're given the output, we can work backwards to get to the input. But if they're standing alone, this is the independent variable, the input or X. The Y is the output or dependent variable. Think of it as you and your parents. The independent variable is you, or excuse me, is your parents, and you are dependent upon them. So there's a lot of stuff there to look at, and we're going to continue to use these math terms. So let's go ahead and start with the guided practice here. Okay. All right. So let's take a look at number 1. We have a function table. All right. We have a lot of reading. Isaiah is buying jelly beans in bulk. They cost $3 per pound, and a candy dish costs $2. So they give us this rule: 3 times x plus 2, or 3x plus 2, where x is the number of pounds, right? Can be found to use the total of x pounds of jelly beans in one dish. Make a table that shows the cost of buying 2 pounds, 3 pounds, 4 pounds of jelly beans in one dish. Okay, so what I'm going to do is plug these numbers in for my X pounds because that's what they are. So we have 2 pounds, 3 pounds, and 4 pounds. These are the X coordinate. This is the input. This is the independent variable. And what we're going to do next is we're going to substitute the number X, or the X with the number. Okay. 3 times 3 plus 2. Now X is 4. 3 times 4 plus 2. Now we have our function rule. Now we're going to go from X to Y. 3 times 2 is 6, plus 2 is 8. Okay. 3 times 3 is 9, plus 2 is 11. 3 times 4 is 12, plus 2 is 14. So what we've done is we found the cost for 2 pounds of jelly beans, 3 pounds of jelly beans, and 4 pounds of jelly beans using this function rule. This is the independent variable. That is the dependent variable. Okay. let's continue on here, and I'll pull this up just a tad for you here so we can see. Now, next up, we have a function table. You're going to notice that we have a graph. This is the first coordinate. And look here, they're telling us that's where x goes and that's y. Horizontal axis, vertical axis. Jasper hikes 4 miles per hour. The function rule that represents this is 4x, where x is the number of hours. Make a table to find out how many hours he hiked when he is going 8, 12, and 20 miles. Then graph it. Okay. These are the miles, so we have to be very careful. So they're giving us the dependent variable, all right? So here we are. This is 8, 12, and 20 miles. Where'd I get that information? Right here. They're telling me it's the miles, not the hours. Okay, so what I'm going to do is work backwards here to figure it out. So 4 times 2 is 8, x is 2. All right, so I plug it in there. What times 4 is 12? 3. So if I work backwards, my x is 3. And lastly, 4 times 5 is 20. So x is now 5. Okay, so now what we're going to do is we're going to go ahead and graph these. And again, they're telling us what is x, what is y. This tells us to go left and right, the second number up and down. So I'm going to go over 2 and up 8, and that's a little bit before 10. Okay? All right, and we probably should put the ordered pair there. The next one is over 3 and up 12, and that's going to be about right there, it looks like. And that's 3, 12. And then finally, we're going to go over 5 and up 20. And there it is. And that's 5, 20. Okay, so we've graphed our x and y coordinates. We filled in our function table, and we fulfilled the function rule. Okay, hope you're feeling pretty good. Let's jump to the next page here and maybe get into a few more. I forgot to circle up for you, so let's go ahead and do that right now. And make sure that we're all doing the correct numbers on the homework. So on the homework, we had numbers 1 through 9. Okay. And let me turn this page. All right. And then we had numbers 14 through 29. Right. So a lot of work here. A lot of work. We're doing them all. Very important. I hope you're doing your work to get this. So let's continue here. We'll do a few of them here. Try to get you going here, okay? Everything's going to be fine. Let's go. All right. We got function tables. Use the function rule to fulfill the output. Okay? So 3 times 0 plus 5 is 5. 3 is x is 3. 3 times 3 plus 5. 3 times 3 is 9 plus 5 is 14. Next one. 3 times 9 plus 5. 3 times 9 is 27 plus 5 is 32. So we have our input, our output. Again, independent, dependent. We fulfilled that. Okay, so let's work backwards here. I'll let you do those ones on your own. We'll do number 3 next. So number 3, they're giving us the output. So what number plus 2 is 2? 0. X is 0. Why? Because 0 plus 2 is 2. The output is 3. What plus 1? 1 plus 2 is 3. It's 1. The next one is what plus is 6? 6 plus 2 is 8. The output is 8. The input is 6. And there we have it. Okay, so we're just mentally doing that essentially, right? Okay, let's take a look at numbers 5 and 6, and then we're going to call it a day here. Number 5. Whitney has a total of 30 cupcakes. The function rule where 30 divided by x, where x is the number of guests, can be used to find the number of cupcakes per guest. Right. Make a table of values that shows the number of cupcakes each guest will get if there are 6, 10, and 15 guests. So these are the guests, then graph it. 6, 10, and 15. Those are the X. So now we're going to go ahead and fulfill this. 30 divided by 10. I'm getting the X number from here. The input, 30 divided by 15. Okay? So this is really, should be mental math, right? 30 divided by 6 is 5. 30 divided by 10 is 3. 30 divided by 15 is 2. Okay? So now we're going to graph these. X tells me to go over. Y tells me to go up. Over 6. The interval was 4 here, so I have to be careful. And up, how many? 5. So I'm going to be somewhere about right there. And my ordered pair is 6, 5. Next one is over 10 and up 3. It's going to be about right there. And that's going to be 10, 3. And yes, I want the order of pairs written down. And the last one is over 15 and up 2. And there you have it. And you're going to start to notice that these will all fall in a line. Okay, we'll talk about that later down the line. All right, let's take a little peek at number 6. And here we go. Bella rollerblades 8 miles in 1 hour. Her function rule that represents the situation is 8 times x. X is the number of hours. Make a table to find out how many hours she has skated when she has traveled 16, 24, and 32 miles. So that tells me those numbers go there. 16, 24, and 32. I got those numbers right from there. Now we're going to work backwards. Well, 8 times 2 is 16. X is 2. Right? 8 times 3 is 24. X is 3. 8 times 4 is 32. X is 4. And that's just dividing them, right? And let's go ahead and graph it. This is again our X over 2 and up 16 should put me about right there. And that's 2 and 16. Over 3 and up 24 put me about right there. 3, 24. Over 4 up 32 will put me about right there. 4, 32. And you'll notice they're right on a line. Okay, so I hope that made good sense. That was a good video. Welcome to function tables. You know what to do. Finish it up.